A Vactrain is a proposed design for very high-speed rail transportation. It is a maglev line using evacuated or partly evacuated tubes or tunnels. The lack of air resistance could permit Vactrains to travel at very high speeds up to 4,000 5,000 mph, which is 6 times the speed of sound using relatively little power. Vactrains might use gravity to assist their acceleration. If these trains achieve the predicted speeds, the trip between Beijing and New York would take less than 2 hours. Surpassing aircraft is the world's fastest mode of public transportation. However, without major advances in tunneling and other technology, Vactrains would be prohibitively expensive. In 2010, researchers at Southwest Jiaotong University in China were developing a Vactrain to reach speeds of 1,000 km/h. They say the technology could be put into operation by 2020. History: Vactrains made headlines during the 1970s when a leading advocate, Robert M. Salter of RAND, published a series of elaborate engineering articles in 1972 and again in 1978. An interview with Robert Salter appeared in the LA Times. He discussed, in detail, the relative ease with which the U.S. government could build a tube shuttle system using technologies available at that time. Maglev being poorly developed at the time, he proposed steel wheels. The chamber's door to the tube would be opened, and enough air admitted behind to accelerate the train into the tube. Gravity would further accelerate the departing train down to cruise level. Rising from cruise level, the arriving train would decelerate by compressing the rarefied air ahead of it, which would be vented. Pumps at the stations would make up the losses due to friction or air escaping around the edges of the train itself requiring no motor. This combination of modified gravity train and atmospheric railway propulsion would consume little energy but limit the system to subsonic speeds, hence initial routes of tens or hundreds of miles or kilometers rather than transcontinental distances were proposed. Trains were to require no couplers, each car being directly welded, bolted, or otherwise firmly connected to the next, the route calling for no more bending than the flexibility of steel could easily handle. At the end of the line the train would be moved sideways into the end chamber of the return tube. The railway would have both an inner evacuated tube and an outer tunnel. At cruise depth, the space between would have enough water to float the vacuum tube, softening the ride. A route through the northeast megalopolis was laid out, with 9 stations, 1 each in D.C., Maryland, Delaware, Pennsylvania, New York, Rhode Island, Massachusetts, and 2 in Connecticut. Commuter rail systems were mapped for the San Francisco and New York areas, the commuter version having longer, heavier trains, to be propelled less by air and more by gravity than the intercity version. The New York system was to have 3 lines, terminating in Babylon, Paterson, Huntington, Elizabeth, White Plains, and St. George. Salter pointed out how such a system would help reduce the environmental damage being done to the atmosphere by aviation and surface transportation. He called underground very high-speed transportation his nation's logical next step. The plans were never taken to the next stage. At the time these reports were published, national prestige was an issue as Japan had been operating its showcase bullet train for several years and maglev train research was hot technology. The American Planetran would establish transcontinental subway service in the United States and provide a commute from Los Angeles to New York City in 1 hour. The tunnel would be buried to a depth of several hundred feet in solid rock formations. Construction would make use of lasers to ensure alignment and use tungsten probes to melt through igneous rock formations. The tunnel would maintain a partial vacuum to minimize drag. A trip would average 3,000 mph and subject passengers to forces up to 1.4 times that of gravity, requiring the use of gimbaled compartments. Enormous construction costs were the primary reason why Salter's proposal was never built. Starting in the late 1970s and early 80s, the Swiss metro was proposed to leverage the invention of the experimental German Transrapid maglev train, and operate in large underground tunnels reduced to the pressure altitude of 68,000 feet at which the Concorde SST was certified to fly. In the 1980s, Frank P. Davidson, a founder and chairman of the Channel Tunnel Project, and Japanese engineer Yoshiro Kyotania, JAR, tackled the transoceanic problems with a proposal to float a tube above the ocean floor, anchored with cables. The transit tube would remain at least 1,000 feet below the ocean's surface to avoid water turbulence. Dr. James Powell, former co-inventor of superconducting maglev in the 1960s, has since 2001 led investigation of a concept for using a maglev Vactrain for space launch, where the Star-Tram proposal would have vehicles reach up to 8,900 mph to 19,600 mph within an acceleration tunnel, considering boring through the ice sheet in Antarctica for lower anticipated expense than in rock. See also: Beach pneumatic transit, atmospheric railway, Swiss metro, transatlantic tunnel, Star-Tram, pneumatic tube, Hyperloop, ET3 Global Alliance. References. External links: Worcester Polytechnic Institute page discussing Goddard's achievements, Vactrains at Orion's Arm, Rail Journal, Popular Science, Hydrogen Tube Vehicle, China plans 1,000 kph super train, cargo cap.